Let's practice a little bit using the product rule and the quotient rule. Um, of course, you should always try to pause the video and do the question yourself before you follow the solution. It's a better way to learn. So why don't we take this function, f of x equals x sine x plus x squared cos x. Let's say we want to do this derivative, all right? Well, when I look at this, you should kind of see that, first of all, it's a sum of two different expressions. So that means we can just worry about doing the derivative of this first, and then plus the derivative of this. What about each of these terms? It's actually a product, right? We have x times sine x, so it's kind of like the first factor is x. Why don't I just rewrite this to make it obvious? This step is kind of unnecessary, but maybe it definitely drives home the fact that we have a product here and a product here. So we're going to have to use the product rule. So what's the derivative of f? First of all, the derivative of this is going to be the product rule. So the derivative of the first is 1. The derivative of x is 1, right? Times sine x left alone. Plus, now leave x alone. And do the derivative of sine x, which is cos x. And now we're at this plus sign right here. We're going to recopy that, plus. And now we're going to do the derivative of this, which is, again, done by product rule because this is a product. So the product rule says to do the derivative of this, we first do the derivative of this first factor, which is 2x, times that second factor left alone, plus, now we leave the first factor alone, and multiply by the derivative of cos x, which is minus sine x. And there's the answer. You could clean that up a little bit, get rid of the brackets. I guess it's not really necessary, but why don't I at least rewrite it a little bit nicer? So sine x plus x cos x. Actually, look here, x cos x and 2x cos x, those can be combined to give us 3x cos x, right? And this last term here, we can write it as minus x squared sine x. So on some questions, they'll ask you to simplify the answer, and some they'll just say leave it unsimplified. As soon as you finish taking the derivative, you can stop. So I didn't really specify one or the other here. But really, I'm mostly concerned that you're getting to this step right now, okay? Because this step is the one that the derivative is fully completed, right? After this step, then it's just a matter of simplifying it, right? So I need you to be able to successfully evaluate these derivatives. All right, let's practice a little bit more. Let's say we take another function, g of x equals, say, root x cos x. Well, that's pretty obvious that that's a product, right? We have root x as our first factor, and cos x is our second factor. So let's use the formula for the product rule to evaluate this derivative. So the product rule says we first do the derivative of this first factor. What is the derivative of root x? Well, we've memorized that. It's 1 over 2 root x. And then we leave this second factor alone. Recopy it, in other words. Then we recopy the first factor, leave it alone. But this time we're going to multiply by the derivative of the second factor, right? Derivative of cos x, we know, is minus sine x. If the question said leave this unsimplified, then this would be your answer. There's really not too much simplifying we can really even do. I guess we could rewrite it like this. This factor can be written like that, right? Of course, you think about this as over 1, and 1 times cos x is cos x, and 2 root x times 1 is 2 root x. And this minus sign can be brought out front, and we can get rid of these unnecessary brackets. And so that's the answer that's simplified. We could even get a common denominator here, just for practice. Why don't we do that? This is over 1, right? So I would like, the common denominator is going to be 2 root x. So I need to multiply top and bottom of this expression by 2 root x. And when I do that, 2 root x times root x is 2x. So it would be cos x minus 2x sine x. So that's the, I would say that's the fully simplified answer right there. But I'm hoping that you're getting to this stage no problem, okay? That's kind of the main thing we're testing here, because after that it's just a matter of algebra, which of course you do need to know how to do. But right now we're focusing mostly on learning how to take derivatives. Okay, so let's try some more. Let's do this one here, okay? F of x is 5x cubed minus 4x cos x. Now, this one here is maybe a little bit, has a little trap in it because of this minus sign, okay? Let me first do it the wrong way a little bit, okay? And then you'll see the mistake that students might make. First of all, this 5x cubed, it's really easy to do the derivative of that. That's kind of nothing. Over here, though, we do have a product. We have like x times cos x. And why don't we think of this as a product by putting brackets here and putting brackets here, okay? So that's a product, right? 4x times cos x. The first factor is 4x. The second factor is cos x. So let's try to do the derivative. The derivative of 5x cubed, that's easy. 3 times 5 is 15, and then x to the power of 2. Now, so I'll write my minus sign here. Now let's do the product rule here, okay? The product rule says do the derivative of this first one. What is the derivative of 4x? It's 4, right? How did I do that? Just on the side here. Remember, if you want to do the derivative of 4x, it's like remember that rule, you can pull the number out front, right? And then multiply by the derivative of x. And we've memorized the derivative of x is 1. So this is 4 times 1, which is 4. All right. Just make sure we're on the same page here. Now, let's keep going with our product rule. So the derivative of the first factor is 4 times that second factor left alone, plus the first factor left alone times the derivative of the second factor, which is minus sine x. Why don't I erase this here? It's bugging me. So there is a mistake here. I hope you see it. It has to do with that minus sign, okay? Let me explain what it is. In some sense, there's kind of like big square brackets here, right? That minus sign is being applied to all of that. So there should also be square brackets here. And now when we get rid of that square brackets, this minus sign is going to affect this plus sign by changing it into a minus sign, right? So the real answer is 15x squared minus 4 cos x minus 4x times minus sine x. So if we didn't have these brackets in here, these square brackets, we would have left that as a plus, wouldn't we? And that would be wrong. So just be careful that I'll say a little bit more after I finish simplifying this. So 15x squared minus 4 cos x, and then this minus and this minus make a plus, right? And there's your answer. So basically, I'm just trying to draw attention to this. Let's say you have, I don't know, some function capital F, which is like, I hope this is not too abstract, but f minus gh or something, okay? And you want to do the derivative of that. If you do this, you do the derivative of the first, and then you apply product rule of this, so you get g prime h plus gh prime. There's a mistake here, okay? Because the real way to do it would be to do f prime is the derivative of the first here minus, and then put brackets and go g prime h plus gh prime, right? And then you see when you get rid of the brackets on the next step, you would have an expression that looks like this. And now this one is correct. Of course, these two are different because here we have a plus sign and here we have a minus sign, all right? So this is the correct one to do here, all right? So I'm just trying to give a little example. If you ever have some weird expression and you have minus a product, make sure you throw some brackets around that product rule there, okay? Or else you're going to be making a little mistake on the sign there. It doesn't come up very much, but it's worth talking about, huh? So let's do some more. How about this little weird one? It's not a big deal, but just to make sure you don't get confused. Let's say r of z is sine z over 2 times cos z over 3. Just some weird function. How do you do this? Well, first of all, I would suggest simplifying it first. You could use product rule, right? And then on each of these, you could use quotient rule, but that'd be a lot of work. Why don't we simplify it first? You know, it's so important to know that sine z over 2 is the same thing as something like 1 over sine, like 1/2 sine z, right? Kind of the general rule of algebra here. I'm just saying if you have like x over 2 or something, this is the same as 1/2 x, right? Sometimes it's nice to write it like this. Sometimes it's nice to write it like this. The advantage of this way, it's like a number in front of the variable, right? Whereas here it's like a quotient. If you were to do the derivative of this, you might think quotient rule, right? Which is a lot more work than doing the derivative of this, which would just be, you know, you pull out the number out front and then multiply by the derivative of x. I hope I'm not confusing you with what I'm saying there. Let's just keep going with this example. So again, I'm going to pull out this 1/3 here. And why don't I just multiply these two numbers here? 1/2 times 1/3. That's 1/6, right? And now we're ready to go with our derivative. To do this derivative, what I'm going to do is use that rule where if you have a number in front of some function, to do its derivative, you just pull out the number and then multiply by the derivative of the function afterwards, right? So in these brackets here, I'm just going to multiply by the derivative of sine z cos z. Let's use a product rule for that. The derivative of sine z is cos z times cos z left alone plus sine z left alone times the derivative of cos z, which is minus sine z. And that's about it. So we could write that as something like this, right? Cos squared z minus sine squared z. And that would be your answer for that one. All right, so just keep in mind, sometimes you should simplify your function before you take the derivative. And this little trick, when you have something over a number, doesn't have to be 2, it could be any number at all. You can really pull that out front to be a fraction, right? All right, good enough. Let's try one more. How about we look at the two functions f of x equals sine squared x and f of x equals cos squared x. What are those derivatives? Well, we don't have a formula for sine squared x, that's for sure. So how are we going to do this? Well, the little trick would just be to remember, you know, sine squared means sine x times sine x. And now this is a product, right? So we can do its derivative. Excuse me. So f prime of x, what is that? Let's use the product rule. The derivative of sine x is cos x. I'm going to leave that second factor alone. And then plus, now I'm going to leave the first factor alone, times the derivative of sine x, which is cos x. So it looks like we have sine x cos x plus another sine x cos x. So we have two of them, 2 sine x cos x. And how about this little derivative? Well, same idea, right? Let's rewrite this as cos x times cos x to realize as a product. And then we can do the derivative, no problem. It's derivative of cos x is minus sine x times cos x left alone plus, now I leave the first factor cos x alone, and I multiply by the derivative of the second factor, which is minus sine x. Now, we have minus sine x cos x and another minus sine x cos x, so we have minus 2 sine x cos x. All right. Okay, so sometimes if you have a square, you can just write the function as a product times itself, and then use the quotient rule. Later on, we're actually going to learn a tool, the most powerful derivative tool, which is the chain rule, in order to do this derivative in another way, but let's not worry about that right now. Okay, so we've just practiced the product rule a little bit. The next video we'll do some questions to practice the quotient rule.